All right, we're back again, and now we're going to talk about an isotherm example and on our PV diagrams. So suppose I have this PV diagram and I have 6.9 pascals and I have 4.8 pascals. And this is 3.0 cubic meters. And I don't know what that volume is. What I have is an isotherm. And obviously this drawing is not to scale. And this is pressure, this is volume. And so as the pressure increases, this is a pressure goes as 1 over the volume curve. Okay. So we don't have our work, which is P delta V, but we do know it's an isotherm. So I want to know what this pressure is, and there's just information I can't figure out on this because there just isn't enough information. So we know that delta U is Q plus W. Well, the thing is, this is 0. So Q is going to be negative W. So if I put work into it on an isotherm, it's immediately going to go to its surroundings and not change the temperature. This usually happens when you've got something that's a very, very slow process in that you're going to happen. It's all of the energy goes to the surroundings. Okay. Well, the issue here is I can't use P delta V because that's not a straight line. And I also don't know the Q because it's not a straight line. And I don't have the final volume. So what's a girl to do? Okay, we're going to go back to our favorite ideal gas relationship, PV equals nRT. And this is just going to be this relationship since the temperature is going to be the same because this is an isotherm. Since the T is constant, we know that P times V is a constant. And so we have P1, V1 equals P2, V2. So now I can find my final volume. So my first, I've got 6.9 times 3.0. And that's going to equal my second pressure, which was 4.8. And I want my second volume. I'm sorry, just had a mental lapse there. So we're going to take 6.9 times 3. We're going to divide by 4.8. And we're going to get our second volume. Those of you who've had chemistry, you recognize this as one of the 3 laws. I'll be honest, don't have those quite memorized myself as to which one is which. But I put this in my calculator and I get my second volume as 4.3 cubic meters, which makes sense because it's bigger than the other one. And so that's what that has to be. So when dealing with an isotherm, the key factors that you need to remember are that the internal energy is not going to change and that the temperature is going to be constant. If the temperature is constant, then the pressure times the volume is also constant. And so you wind up with that situation. All right. Stay tuned for the next example where we will be looking at straight line curves and really deep diving into our PV diagram. Hang in there. We're all in this together.